thanks for checking out this 3D Scout video. So I thought this would be a perfect time to just do a quick sort of mini product design video for Fusion 360. It's going to include some silicone molding as well. So, you know, a lot of people have gotten into making different molds out of silicone and different things like that. So I decided to go ahead and buy a vacuum chamber, because a lot of times you either use a vacuum chamber or a pressure pot for silicone, or stabilizing wood, which I'm going to do in the future as well with this vacuum chamber. I'll get a pressure pot eventually if I can afford it, which I can't right now. So like and subscribe, maybe help me get there. So there's not many options left for vacuum chambers unless you want to spend, you know, crazy amounts of money. So I bought one of the more readily available options, Vevor, who for whatever reason decided to make literally like everything. It seems like they make every time you Google something, it's like, hey, I need to buy this. It's like, oh, Vevor has an option. Okay, well, this is the first Vevor purchase I've ever done, and it's only because there's not really many other brands out there. There's a lot more for pressure pots, but for vacuum chambers, this sort of seems to be it. So this is the lid that came with it. I don't have the full thing right here. This is the lid that I purchased with it, and this is the pressure gauge, the vacuum pressure gauge that came with it. And I have to design a product to get this to work, which is crazy, but I should have expected as much for buying something from Vevor. Anyway, so it's pretty much just a 5-gallon bucket. I'm sure you may have seen it before, a 5-gallon stainless steel bucket that you put all your stuff in. Then you put this lid on top. That silicone that they provided helps make a seal. And then you have to, this is how you actually pull the vacuum on it. This attaches to that hole right there. And then your vacuum pump attaches to either one of these, whichever is easier for you to use. That one's a female socket. This one's a little barbed hose, both 1/4 inch. And then it reads out, you know, what your current vacuum is. But wouldn't you know, the little gaskets that they provided that went around this section here were so small in diameter that they went straight through that hole. Straight through it. How's that supposed to make a vacuum? And so I get in contact with Vevor over like the span of at least a week, going back and forth with them, explaining the problem, having to send pictures like, hey guys, this doesn't work. This doesn't even look like what's in the manual. But even if this was what was in the manual, this doesn't make any sense. There could be no tight enough seal to pull vacuum. So you'd have a gasket on there, you put that there, you put the other washer on there. But even that washer alone is almost a small enough diameter to just go straight through that hole. So I don't know what they were thinking. They apparently don't even know what they were thinking, because they can't locate the right gasket. They didn't even contemplate just trying to send me a gasket. So they gave me like a $22 refund off of what was like $80. So, and I checked the gaskets that I have, the silicone gaskets that I have at the house, because I have the spare ones. Don't have anything that's gonna work. So I decided, hey, let's just make one, right? I've got the silicone liquid that you can use to either cast something in silicone or make a mold from silicone to then cast other things in. So we are going to design what this needs to be, and then we're going to 3D print a silicone mold, and we're going to pour that silicone in there and then let it set up, and then it should hopefully work. So yeah, I figured this would be a great project. So when starting any project, you have to have some specific pieces of information. One of them being technical specifications like diameters, lengths, distances, things like that. So get out your trusty pair of calipers, preferably digital if you have them or can afford them. Some people prefer the manual ones. I'm going to just do decimal inches. Sometimes I do millimeters, but actually I'm going to just do millimeters today. All right, so the only requirement of this is really, you know, the material is going to be silicone, because that's a good sort of amorphous material that can help create a sustained vacuum by being pulled into a location where there might be some leakage, and it can sort of adjust itself. So that's what's good about this, as opposed to, you know, just a piece of steel, like a steel washer like that. That's not going to be very helpful there. So the silicone material, and then the other requirement is just to be capable of providing vacuum, right? So beyond that, really all we have to gather is some specific measurements. And you may have bought a Vevor vacuum pot. This one may not be exactly the same. So these dimensions may be different for you if you have the same problem, because I can't be the only person that's suffered this before. I'm at about 19.68 millimeters. So we're going to oversize that a little bit, obviously, because silicone can change shape a little bit, so we can sort of force it in there and it'll absorb a little bit. So we're probably going to go just a straight 20, just round it off to 20, maybe even larger. We're going to do a test at 20 and see if that works, and if not, well, then we'll increase it. So what I'm imagining is something, one singular piece that's going to have a sort of flat flange that sits on this flat part on top here, then a sleeve tube that goes through the hole, and then another flat flange thing here, because it's silicone, it'll bend and I can get it through that hole, and then it'll pop into shape, and then it'll be perfect and ready to go. So I've got 20 as my diameter. I'm going to get the depth here. So the depth of the hole is about 21.44. We're going to go smaller on that, actually. Because again, the amorphous nature will allow it to increase in size a little bit. And we want this to be a tight seal, so we're only going to do maybe 21. So 21 diameter, 20 diameter, 21 height. And then beyond that, what we need to know is the diameter of this, that this thing's going to, the silicone's going to sit around. So this silicone will sit in here, and this will sit in the silicone. So this is really the only other piece of information that we need, I believe. So that's 13 millimeters. So again, we're gonna go small on that. So it'll sort of have a nice grip on this. So maybe 12.75 or so. That's gonna be not much, maybe 12.5. And if my 3D printer is fairly dimensionally accurate, that'll actually be close to what I am wanting, 12.5. Maybe smaller, and if so, then we'll just increase that size in the program later. And so that's it. The height of this doesn't really matter, because this is gonna screw down onto it with these two washers. I guess it would be nice to know the maximum distance I can go. No, so we're just gonna use the 21 height and add probably 2 or 3 millimeters on the bottom and the top. So about 25 to 26 or so total height of the silicone. And I just wanna make sure that that will actually fit in here. So I wanna know what my maximum allowable height is with this nut being on here. So that's on, but very loose. And we've got, so that's only 21.46. So we actually are fairly limited. Who'd have known? We have a stick under 21.46 on the total height of the. All right, so thankfully I actually made a little mistake in making this one measurement of the depth of this hole. It's surrounded by this silicone ring on top and bottom. So actually the glass is slightly less than 21.46. So if I put something that's flat with the bottom of the glass, now I can actually take a depth measurement. So if I do that, it's about 19.2 millimeters. So we have a few millimeters to play with on the total height. So I'm going to jump over to the computer recording, and we're going to go ahead and get this going in Fusion 360. Okay, so here we have an open new document for Fusion 360. So we've got our measurements. So I would say it's probably easiest to just go and start with the bottom plane there. Let's go ahead and change our dimensions to millimeters. That's what we took our measurements at. All right, so the center diameter was 19.8 something, but again, we are going to actually go over that. But I'm actually going to model the specific hole as an object, and then we'll actually see everything. It'll help just visualize it. So this is essentially glass, and again, the height of that about 19.1. All I did there was I made a sketch after taking the dimensions. This is just a random size. I don't really care how what the diameter of the actual glass is. That's not going to matter for us right now, or at all. So that's just random. So this is the more important one, the 19.86. So you just do a C on your keyboard, and that'll allow you to do a center point circle there. So I did that, and entered the diameter right there. Then I just did this other one. And the strategy behind this is just to actually be able to fully see what we're actually working with. That way, when we see our product that we design around it, we know it will actually work, and that all the sizes that we're either going too small on or larger than or smaller than the actual measured dimension will be the correct ones to make sure that this is a tight seal. All right, so if you don't know how to extrude, if you don't know how to use Fusion at all, this probably isn't the video for you, but I will sort of try and walk through exactly what I'm doing. So once I have the shape that I want to extrude there, just click E, you click on the actual thing. You could actually click on that. We don't want that though. We want that to be a hole. We want the blue part there. So let me just enter the dimension that we want, 19.1. Click enter, and there we go. We have a solid. You can see that over here in bodies. There's our sketch. You can turn that off. It automatically turns off after you extrude, but you can turn it back on later to reference it. So this is what we're trying to design around. There is like a tiny little chamfer on here on the actual glass, but I'm not gonna, that doesn't matter for me. It's nice that it is there, but it doesn't really matter for our purposes. So just not gonna even leave it in there. But if you wanted to chamfer something that's under modify, chamfer right there. So now what we're going to do is we're going to make a component out of that. Create a component from bodies. Components are nice to work with because they don't necessarily, it's just its own whole thing. We're creating a single body as a product, but this is outside of that product. We are creating this. So we want components, and everything inside of a component should be one singular body typically. It can be made up of subcomponents, but we're not going to worry too much about that right now. So I'm going to make a new component up here under a symbol. Name this silicone gasket. Some of these things are unnecessary, but it's just a form of best practices when designing to keep all of your operations succinct with each other. So if I click on this component, it's going to have, well, if I had done everything in that component, it would have all of the operations that I did. So you see these operations down here. That's what I did. I drew a sketch, I extruded, then I moved that body to a component, and then I made a new component. So we're going to go here. Now we're going to do all of our drawings in this. So this is how you select a component. The unsaved thing up here, that's the parent component that holds every single thing in your document. So I'm going to click here, hover over it, a little bubble shows up. You click that, and everything else sort of gets grayed out. You can see it, but it's kind of translucent. That helps you know exactly what you're working on. Everything that we are going to now be working on is going to be this solid gray color. This helps you know what you're working on. So we're going to click C to draw another circle, and we can choose a face to click on. I'm going to just click on that top face here. So what we're going to do is we're going to draw a circle here. So this is going to be our top rim. So what I'm going to do now is I'm going to measure the washer that you saw me messing around with earlier, because we want that gasket to be at least that same diameter, maybe a little bit bigger. This is 24 millimeter washer. Both of them are. So we want this to be a 24 millimeter diameter. Actually, go a little bit bigger. Let's go a little 26. So now what we need is our inner circle. This is, oh, I don't know what in the world just happened there. We're going to draw our inner circle. This is what's going to wrap around the stem, the brass stem that goes through the glass. Again, that brass stem is about 13, almost exactly 13 millimeters. So we're going to go a little bit smaller, go at 12.5, sort of have a nice friction fit on that. So we're going to go 12.5 on that circle. So now this is starting to take shape. We want the rim that's going to go inside the glass hole to be actually a little bit bigger than that. So we're going to go actually like maybe 20.25. We could maybe just do 20.5. I mean, we're talking millimeters here, so that's not much of a change there. So I'm going to go 20.5. And you can see that this is the hole of the actual glass. So that's going to be essentially the friction fit right there. The difference of those two distances right there. So we want this to be as tight as possible. So it's going to be squeezing on the brass tube, and it's going to be pushing out against the glass cylinder hole there. So let's go ahead and actually turn off that other component. We don't need it anymore, really. So this is going to be, that and that actually, is going to be the inner wall that goes through the glass hole. So we're going to extrude that out again. Just either click E and select what you want, or select what you want and then click the E on the sketch profiles to extrude. And our depth again is going to be it's nice to write these down in Excel or something on your phone. So the depth is 19.18. So to keep a tight fit on the top and bottom, we might want to cut that down a little bit, maybe 18.9. So let's go negative 18.9. That would be the depth of that. And see, the sketch disappears when you click E. You might be able to turn that off, but you can always just come down here in the design tree and turn it back on. That little eyeball. And then again, all the things that we were doing in the silicone gasket component are down here. All right, so now that we have what's going through the glass figured out, let's go ahead and just click E and then click that, and that, and that. And all of this will go up. Maybe we'll start at 2 millimeters. We got to remember we have a limited height that we have to work with. You can see that this is still here because it's on that sketch we turned on. You can click that and then click V, and it'll V will change between visibility. So that made it invisible. So now I'm going to come over here. This is the other side. We need this same flange thing here on this side as well. So what we're going to do is just click C, and we can click that plane. That part of the object is a flat part, so that can be used as a plane. And what I can do is click P, and I can come down here and click on this, and it'll actually project. P is for project. That same thing, so it's going to be the exact same dimension and everything. And we just click E and select those two, and we're going to go up again 2 millimeters. So boom, there we go. Now because I'm doing all this in a component, these extrudes, they're all going to create a singular body. They're all going to join with each other. Now we could change the operation to join, cut, intersect, or new body when we're doing the extrude feature. So if I change that to new body inside the component, it's actually going to make a new body instead of joining those two. But I don't really want that. I want them to be joined. So there we go. That's our silicone gasket right there. Easy enough. Very simple product. It can use a lot of different aspects of product design. Things like dimensioning and tolerancing. So we're actually going over the dimensions because again, we want a tight fit, and silicone will give and just make a tighter fit. That's a huge part of product design, is dimensioning and tolerancing. The tolerancing we're not going to really worry about, but the dimensioning is huge for us right now. Tolerancing is like when you're sending it off to another manufacturer and you will refuse to accept a part that is where this diameter is so much percentage or so much millimeters off of what you specified on a drawing that you sent to them. You can say, hey, let this be a 10.25 millimeter radius plus or minus 0.05 millimeters. So 5/100 of a millimeter, 1/10 of a millimeter, plus or minus 0.05. is your tolerance. If it's outside that tolerance, then you're going to refuse to accept the product. That's good to do when you're working with other people. I'm just 3D printing this at home, so let me just type this real quick. All right, now that we have that saved, this is what we're going to cast in a 3D printed mold. So we're done with the product, at least for now. This is going to be our first prototype test piece. If any of the dimensions that we did were too tight or too loose for whatever reason, we can go back in here and change them later. But this is where we start. The next part is we're going to make a new component. If I made a new component with this selected, it's going to be a subcomponent in silicone gasket. And that's not what I want. What I want is I want to make another main component in the entire project. And I realize those are named the same. That's just because I named the file. This is the name of the file that you're working at. This is the name of the component that you're under. I just happen to name them the same thing. You can see one's lowercase, one's uppercase. They are different things. So I'm going to go to the main component, which is everything in your drawing. And I'm going to click new component, and I'm going to say gasket mold. All right, ta-da! And now this is slightly translucent. So I'm going to just do a cylindrical shape for my mold because this is a cylinder. It just makes sense to me. You could do square, you could do whatever shape you want it to, as long as this fits inside of what you're going to do. So I'm going to take this route. I'm going to construct a plane. I'm going to go to this is the bottom. Looking at the bottom. Kind of backwards on my. Wait, where's. Okay, it's because it's see-through. I can't really tell what's going on. All right, there's the bottom. You can tell by looking at this little cube here that shows all of your directions and everything. So I'm going to go down maybe 5 millimeters. Will that be enough? It's hard to see anything. 5 millimeters should be a big enough wall for a mold, at least I would say, at least for now. So we're going to start there. That's my plane. That's not an object. That's just a plane that we can draw on. So I'm going to click C. That's going to automatically take me to the circle, center point circle. I'm going to click on that. And I'm just going to make a diameter larger than what I'm actually wanting to cast. I'm going to do maybe like 35. None of these are set in stone rolls. I'm just sort of going from the hip here, making up numbers and seeing what works. So what I'm going to do is I'm going to finish that sketch. I'm going to extrude this. I'm going to click up to there. That's going to take me to the top of my gasket. And then so that reads negative 27.9 millimeters. So I'm going to have to minus another 5 millimeters off that. Click new body. So that's what I want to do. There we go. So now I've got a 5 millimeter gap on the top and a 5 millimeter gap on the bottom, and then a few millimeters radius on both sides. Now my gasket is inside of that. So if I hover over this, I can actually see it in there. If I click on it, it'll turn blue. So this is going to be the outer cast. So now I can really just sort of get rid of that for right now. Actually, what I'm going to do before I disappear that, I'm going to go ahead and split body. I'm going to split the body of the mold. Convert your body to split, selected that, and then splitting tool. So the tool I'm going to use to cut that mold is the thing I actually want to cut out of the middle of it. So you click that. If it's not grayed out here, that means everything's good to go. Click OK. Now if I go look in the bodies tree here, I've got the inside body. So that was actually what was removed from the other one. So if I turn that off, leave this one visible, and then make the actual silicone gasket, our product, disappear. I can go to utilities, section analysis. So section analysis is going to let us look through the parts. I'm going to click here to select a plane, and we can go actually look through our part. It helps us just see the interior. So that's actually where our silicone is going to actually flow into and then solidify into the shape of our product, a silicone gasket, which is what we want. The section analysis just helps you realize you can take inside measurements that you wouldn't be able to see otherwise, because like, look at this, can't see anything. So now that we have that inside cut out, what we need to do is actually make this be a usable mold. So to do that, you have to be able to cut this thing in half. So we're just going to click the sketch button and then click on the plane that we want to sketch on. So typically you want it to cut exactly in half. We're just going to draw a line there. We can click that and select X, and then it'll just be a construction line. It'll actually just be a dashed line, which is hard to see with that there. You can see if that's a dashed line, maybe. It's not making the dashes larger when I zoom in. But that construction line won't be extruded if you were to extrude an object. But what we are going to do with that line, now that you can see it's an orange dash line, it's a little easier to see there. We're going to split body, we're going to click this body, we're going to click splitting tool, and then we're going to select that line. It's going to, no, not the plane. Line is hard to see. Oh, it's not letting me select that. Turn that body off, maybe. Maybe it won't let me do it with a construction line. Go back into that sketch. So if we come down here and we see all these different operations that we've done in gasket mold, we can actually double click on that, and it'll take us back to that item. So I'm going to click that line. I'm going to make it an actual line, not a construction line. And hopefully we should be able to split that body with that line. There we go. So you can see that. You can hover around and see that it's going to slice all the way through that body, just like that. Now I've got two body parts. I'm going to disappear this one and see, there you go. That's the interior. That's another way. This is essentially a section analysis view, but we've actually cut the part in half now. So we will have to add some indices, essentially, a channel here, and then a rim on the other side, so that these actually index into each other properly, so that things aren't misaligned. Because like if we were to do this, and then if these things weren't indexed, then they could be like askew like that a little bit, and that's not what we want. That would not make a silicone gasket mold that we want. So what you do is you have to make sure that you don't put any indices that are going to make it impossible to get apart, obviously. So this part, what I'm actually realizing is we're not going to be able to get this part off, because it will actually destroy the gasket to do so. So we're gonna have to actually do a 3 or 4 part mold in order to actually get this thing off, or the silicone mold actually out of it. This is where mold making becomes really an art form. So what we can do is we can split this body here. Well, actually, I want to do both of those bodies. So I want to split 2 bodies, that one and that one. Okay, let's click a little slower. I want the splitting tool to be that. Okay, so now we've split the top for both of those parts. So now essentially this top part of the silicone mold and this cylindrical part would pull out, but this bottom rim wouldn't pull out. So we're almost ready. The next part is we need to separate this part from the sides. And I believe what we can do, I'm gonna go to split body, select both of those. I want to split both of them. Oh wait, it didn't select anything. Oh wait, yes it did. There we go. So I'm going to turn one of those off so you don't see it anymore, and then I'm going to split it right there. And that this part will lift off after the mold is done casting. So actually what I want to do is I want that to be solid part. If you right click, you get a quick little recent button here, and then a few other popular things, and then this drop down menu. I'm just going to repeat combine. I'm going to combine that with that part, and then we have that, and then we have the top part. So this top part can be one whole piece, that can be a whole piece. So what's going to happen is after we pour in the silicone and it sets up, and we're good to take this thing apart, what we're going to do is, in order of operations, we're going to take that top part off. Then what we're going to do is we're going to take that piece and that piece, pull that out, and that will come directly out of the middle of the gasket. Then what we can do, so when I do this, the gasket should still be up here because that lip right there, that's not going to let that pull down with this. So that will be continuous there. The part will be suspended inside of here. And then what we'll do is we'll just take that off, just like that. And then you can peel it out. So that's the problem with mold making with more advanced parts. And this isn't even an advanced part. This is incredibly simple. But it can take a lot of thinking through. So that is our mold. What we need to do now is get a way to get silicone mixture into it. So what I'm going to do is I'm just going to project. So I'm going to click P. I'm going to click this. And what I'm going to do is so if I select this blue thing, it'll actually put a little blue dash line under here, so I know what's what. So if I click that, you see how this is blue now. Now I know I can make that disappear. And now I can click on some things here. So what I want to actually do is I want to project this diameter and this diameter. Now, what that tells me is, well, gives me that. Now I can make full-size circles there. So now I know if I make another circle, say, I'm going to draw a line from that point to that point. And now, when I have a line there, Fusions is smart. If I see that little triangle, that means I'm in the midpoint. So if you come up here to these constraints are incredibly powerful. They're in most drafting softwares. But the triangle is midpoint. There's all these other ones. I highly encourage anybody to take a look at all those and get used to using them. Constraining your drawings is incredibly important and powerful. So there may be some benefit to putting the hole that we're putting the silicone in right on a seam line or not on a seam line. I'm not super professional with or experienced with doing silicone molds, so I'm just going to do that and see how well that works. So I'm going to select the midpoint, and I'm going to go not all the way to the edge there like that. I'm going to go in a little bit, so maybe like 5 millimeters. And you want to be careful not to make it too small, to make it so where it won't actually flow in there. You need to get some kind of syringe or something, some way of actually injecting that into that hole. So make sure the hole you're doing is not too small for whatever syringe or injection method you have. I'm just going to extrude that down. And ta-da! So that's one way to get the silicone in there. Another thing you're going to want to do is make it to where air can escape, and then some silicone actually can escape. You don't want air bubbles getting trapped in here. This is one of the reasons why you use a vacuum chamber or a pressure pot, so that if a pressure pot is used, it'll just shrink those air bubbles down to relatively so small you won't even know that they're there. The vacuum chamber will help pull them out. So it's just depending on how you want to approach that problem. So if I do a hole over here, just opposite that, then the silicone should flow in, hopefully would fill in and not have any air bubbles in there, but we're talking about pretty tight tolerances here. Click the inspect there, go from that to that. We're talking 2 millimeters. That's pretty small. So air bubbles might get trapped in there. When you're injecting this with silicone, you're probably going to want to agitate it quite a bit, just roll it around in your hand while you're injecting it, so that you make sure that all those air bubbles get pushed out. Silicone gets in those little crevices, and then the air bubble gets pushed out wherever you put your air exit hole. Now, if I put an air exit hole here, well, I mean, that might work, but then silicone is going to start pouring out here without this part being fully invaded with silicone. So I think the best part would be, if you're doing like high pressure injection molded plastic, then it's going to invade all those parts regardless, because you're talking about insane pressures. So you could put your exit hole down there. Sometimes there's mini exit holes and injection holes to make the process quick and to make sure all the air gets out. So what I'm going to do is I'm going to actually go back to that sketch real quick. Going to go over here, draw another line, and do another circle on the midpoint and make that one 5 millimeters as well. That seems to be the simplest and easiest thing for me to be able to get this this project completed. Now, this essentially should work. You're injecting through here, it should fill up everything. Hopefully there's no air bubbles. You shake it around, get all the air bubbles out. It can hopefully come to the top, and you would probably want to angle this in your hand a little bit, maybe like that. Well, of course, it's just going to be the sketch objects, because that's all on bodies. Select. Of course, set pivot. Set that right there. There we go. Oh, that's not at all what I wanted to do. Sorry if I'm giving anybody a seizure. I got my pivot set. So you're probably going to angle it like this, so that the silicone obviously fills in like this. And then the air is the last thing to come out. So then once you see silicone actually come out of this hole, your part should be complete. You cap it off or do whatever you want to do. Maybe put a clamp on it. Keep everything from seeping out the sides. And you should be good to go. But there are still some things we want to do. Like I said, we want to do indexing so that these parts mate with each other in the exact orientation that you want. So what we're going to do is, you have to keep in mind how these things are going to separate. So this top would come off as the first step. So what we can do is well, first of all, get rid of that sketch. So I would say make just a tiny little rim on this piece. Okay, so we're gonna make a tiny rim around this whole piece. That'll help index the top to this piece. Maybe help some of the silicone from just gushing out the side. So it's gonna be pretty simple. We're just gonna click C. Actually, before we do that, let's make sure we're working in the correct component. Let's click that, drop that down. So because we're modifying these bodies, we're not making a new body, so that'll be fine. We're just gonna click C, we're gonna click that plane, because that's what we're drawing on. We're gonna select the middle, because that's where our center point of this new thing is gonna be. And let's go ahead and let's go to the middle point of that. Let's actually make this, let's select that and click X. Now it's a dashed line, that's a construction line. Click O to offset this line. We're going to offset that some distance. Let's say, how big is 1 millimeter? Let's go like 0.75 that direction. Let's click that, click X to make it not a construction line. We're gonna click O again. We're gonna do negative 0.75. We're gonna click that line. We're gonna click X. Now we have a piece to extrude. Let's see, we don't need it to be super high. Let's just go like, when I'm thinking about things like this, a lot of times I'll bring out my calipers and just measure out a certain distance and see what that actually looks like. Because it's easy just to talk in numbers, but until you visualize it. So 1.5 millimeters on the calipers is pretty darn small, but I think it's large enough. So we're gonna go 1.5. So it can sort of look bigger here. Oh, and you see what it did? I didn't click new body. It just joined everything. So it joined everything that's touching other pieces. So that did not do what I wanted to do. What you have to do here is click new body. See, now these are still two separate pieces. That's just new. Okay, that's just floating around in space. Because that's floating around in space, what I'm going to do... I just realized all these are separate bodies and not components. It's not a huge problem. It's not necessarily the best way to work, but we can worry about that later. Anyway, so now this is a separate body. It's down here. All we have to do is just click combine. Just going to capture the position. Capturing position has to do with when you're dealing with components, which we are. So we're just going to join those two bodies. Now what we can do is we can go back to that sketch, turn it back on. Extrude that again, 1.5. We're going to go over here. We're going to click new body. And then we're going to join those two pieces only. Join. Now we've got a little rim around the side. We're going to hide both those sketches because we don't need to see them right now. So now the best thing to do would probably be to, let me go ahead and I'm going to go ahead and make some components out of here. So all I'm going to do is click on that, right click, create components for bodies. And I'm going to name that. I'm going to name that. All right, if I'm looking in the front, this is the front bottom molds piece. Okay. It's like that one. Create components for bodies. Say back bottom piece. It's good to name these as appropriately as possible and as much as possible. That way, when you go to 3D print them, you know exactly what you're bringing into your slicer software. So this is the mid back piece. This is the front. Mid front mold piece. I should have done it the other way. I did front and back here. I probably should have kept that convention, but whatever. Not that big of a deal. All right, now we've got our top piece, which, because I moved that component, this is not in the same place anymore. Do those. All right, so there we go. Let's create a component. This is the top mold piece. All right, so capture the position because I moved components just so it knows where it is in space. So what I'm going to do now is I'm going to cut the top using the two mid pieces, which I have to cut with the body, not the component. So now that will cut that little raised part, or whatever you want to call it, that part, I'll cut it out of this. So now we can go on the top mold piece, bodies. I'm going to actually put that back where it's supposed to go and then hide those. We go here, go bodies. Take that one and just remove it. I don't want that anymore. It's not necessary for us. So talking more about the dimensions and tolerancing, what we want to do with this chamfer here is that would be, if my 3D printer was
perfect at making what I tell it to, that these two pieces should relatively fit together. And that would probably be, I mean, if it was exact, then it would slide together perfectly. It would more likely be a friction fit if you could even get the thing on there, the top onto the bottom part. So what we're going to do is we're going to use this press pull, which press pull is great. It does really anything. I could select that, and then I can widen and do all sorts of things, which normally I'd have to go create a sketch, create a circle, and do all that at a certain diameter. Well, what I can do is I can just click that, and it'll know what I'm clicking on. That is going to allow me to extrude that more or less if I want to. It's going to let me to grow or shrink that if I want to, which is exactly what we want to do. So we want to take this, I'm going to increase this diameter, or really decrease this diameter by a small amount, to like 0.01. We're talking about millimeters, so that's 1/100th of a millimeter. It's very small. So I'm going to click accept that, and now I'm going to go back and forward, undo and redo. You can see how much that's growing that by. It's barely moving. So that's where you start to play with different amounts for how much you're going to grow this or shrink this, so the parts will slide together perfectly. And that's going to depend on what machining method you're using. It's going to depend on the actual machine you're using. Two machines could be exactly the same, but have different tolerancing, just depending on how well they were set up and maintained. So I'm going to do that to both sides, the inside and the outside. So I'm going to -0.01. And that's probably not enough. It's a very small amount of space. So we're going to actually click back into that. And I'm going to do like let's see how much 0.05 is. Keep in mind, this doesn't have to be a perfect friction fit. I just want these things to index to each other, so things are relatively in line as they're supposed to be. In axial, I guess you'd say. So I'm going to also press pull the top, and I'm going to reduce that by 0.05, because the height of the part that we made might not be exact. So this may be a little bit higher than I really want it to be. So I gave a little cushion. That's what tolerances are for, is for cushion. So what I'm going to do now is I'm actually going to turn that back on. I'm going to show you this section analysis. So let's see, let's make a section right there. So what we can do is we can visualize what we just did. See that gap right there? That gap did not exist before we did the press pull. It was exact. The two lines were right up next to each other, just like these are. But this gap is something we created to give ourselves a little bit of cushion. And hopefully in the real world, that'll be much smaller. I am printing on a Bamboo X1C, Bamboo Labs X1C, if you're interested to know. I'll show more of that later. So we're good to go for that part. So we can go ahead and hide that. It's relatively done. I don't think we'll do anything else to that specifically. So now we have to get these two pieces to index to each other. So I'm going to do the same exact thing. I'm going to hide that one. I'm going to hide this piece too, since we're not working on it. I don't want to accidentally alter it in any way. And we're not working on this piece either. So this doesn't have to be like a super uniform fit. Like we don't have to, you know, make it look exactly like the shape. We could do something like this to get it to index with itself. You're probably good just to do something like this. So I'm going to just go like -2.5 on that side. And I just clicked P over there and selected the face, and that gave me the perimeter. It projected to that perimeter. Selected, do -2.5. So that gives us a good little place to, oh, why is that not, there we go. So I'm gonna, I guess I could either go in or out with this one. So I'm gonna go out with this one. I guess 2 millimeters. So now we unhide the other mid piece. Back to solid. I'm gonna split this body using the other body. And you can see here, I want to select this whole body. If I just select like a face, it's going to just think, hey, I want to split it with that face, which I could cut it in half at that face, but I don't want to do that. I want to cut the whole body, because those two parts that we just extruded out of this body are included in the totality of that body. So if I select typically a corner, see how I have these two planes come together, it's going to think like, hey, he's not wanting that line, because I could just select that if I wanted the line. I'm wanting actually that whole body. So click a corner, and you'll be able to, it'll select the whole body automatically. Click OK, and we've got an error. Why do we have an error? Feed failed. No intersection between targets. Split tool. That's interesting because oh, okay, why are they still there? That's interesting. Where are these? Oh, they're in the bodies up here. Okay, so let's take these, let's put them in, well, which one's which? Not that one. Nope, not that. Goodness gracious. This. Right, so let's combine that. Hopefully that'll keep it all in the mid-back mold piece, and it did not. So I think what you have to do is you have to select, if you're wanting these bodies, which are outside this component, to join this component, I think you have to select that component first. So let's try that. Tool bodies, there we go. Boom, boom. And there we go. Okay, so yeah, select the main body. You want to join the other two first. And there we go. Now we got that one piece. Let's bring this piece back. Let's split body. Select the corner. Okay, we got a split, or at least no error anyway. Hide that. Now we have those two pieces there. Select that and that. Move those, and ta-da, now those will index with each other. So we are good to go on those two pieces. Got the indexes at the top and indexes with each other, and now we have to index with the bottom piece. So let's bring those two there. Let's actually move those down just to sort of get an idea of what we're looking at. Okay, so because if I did some project offset line here, it might actually not meet up with that. It's probably better to do it off at this one. So let's undo that move. Let's hide the mid piece. Hide the mid piece. Let's collapse those two so we're not looking at them. Oh god, these two right here. So these two right here, we're going to just do the same thing we've done. I'm gonna click C, click there. Middle, go to the middle point. You can leave this as a normal circle right now and just do the same thing and then hide it later. So because we have a thinner diameter here than we did up top, I'm just going to do 1 millimeter as opposed to, well, we did 0.75 earlier, didn't we? Whatever we did, I'm just going to stick with this. That way they're different sizes, they won't fit into each other and they get mixed up somehow, or somebody else get mixed up. If they're using this model, I'm going to put this model online for people to download if they want, in one form or another. Okay, so now we have that. Let's click that, click E, extrude, let's go up. I did 1.5 earlier, let's just stick with that. New body, it selected that automatically. And something I didn't do is I should have probably gone into that first before I did that. But this is where we are. I do 1.5. And I do want it to join to that body because it's the only body in that specific subcomponent. So that's one reason why it's good to click into the component that you're actually working on. So I'm going to click into this one. That sketch disappeared, so I'm going to highlight it, make it visible. Root up to there, join only to that one. So now I'm going to bring up the mid pieces. That's kind of cool. You can see through them because they're translucent. And this does help too, because that helps me see that there's some distance between those, which is good. There's distance between those, which is good. All right, so split body. I'm gonna split this body with that. Okay. Right click, repeat split body. I'm gonna split the mid body with the bottom body. Okay, we're good there. Now we're going to end. Well, actually, I don't know where this operation went. The split bodies actually went to the main component, project main component, which is probably because I was doing operations on a component that I had selected specifically. Just know that sometimes you can find your operations in the main component. Other times you're going to find them just in the actual child. So select this piece, go there, bodies, remove that little cutout piece. So many components now. There we go, remove that. But I just remembered we did not make tolerance for these with this index system. So I'm going to do the other kind. So let's see, let's click on that and click V to hide it. And instead of making the hole a little bit bigger, I'm going to press pull on the actual little stub here. So I'm going to reduce it by 0.05. I'm going to do that to all sides, 0.05. You got to pay attention to your positives and negatives. Obviously, if the arrow is pointing out this way, I want to go inward, it's going to be a negative, so negative 0.05. Sometimes it'll switch it on you. You got to pay attention to which direction that arrow is going. So we're going to do the height there. That arrow, I'm pretty sure defaults to usually adding volume, not taking away. So if you're trying to take away, it's usually going to be a negative number that you have to add. All right, so now we're good there. So you can either increase the hole size or the, whatever you want to call that, the jut out size. There's a better word for it. I just can't think of it right now. All right, so now we also need to do that same thing to this bottom one here. So I'm going to do this midsection. So I can actually select that, and then once I know which piece it is, this piece here, I can actually isolate that. Turns off all other bodies and components, so you can just focus on this. That's another good thing to be familiar with, so you're not getting overstimulated by all the things to look at. So, okay, let's go there. I'm going to do negative 0.05 again. Let's pull. Negative 0.05. Also, save often. Every time this program lags, even though I've got a really decent computer, every time it lags, I'm like, oh dear, I didn't save recently, and I'm going to lose all my stuff. Okay, so now we can right click on that and unisolate. That's going to bring up visible what was visible earlier. But if I want to see everything, you can click show all bodies. But what I'm trying to show is an actual component. So, okay, why is the other component not showing up? That's interesting. It should force everything visible, but it's not. Show all bodies. It's not making that body visible. That's weird. Typically, that's what you do. There we go. Okay, now I can see everything. Just go to this one. Isolate that. Press pull. Negative 0.05. Negative 0.05. That's the next one. So now we have. Leave everything indexed. That indexes with that, and we made the gap. We don't really need a gap there because we have a gap up there, so that's fine. Let's grab the bottom piece. We need to make the two bottom pieces index with each other. There we go. So we have to get these to index with each other. So let's just hide the front one. Let's click P for project. Project that whole perimeter. We're going to offset. We're going to go in until we just see something like this. And we can go in, let's just say -3 millimeters. Extrude with E. We're going to click the thing we're going to extrude. We're going to go 2 millimeters. That looks plenty long enough. To unhide the other one, split body, split it with that other body. Okay. To go to the front piece because that's the one that has the extra body now. It's typically body number 1 when you cut something out. Your second body, for whatever reason, is going to be the one you actually want to keep, depending on what you're designing. All right, now we're going to hide that back one. Go in here. Press pull. 4.5. All right. If I'm not mistaken, that's every piece indexed with all the other ones. Let's just do a little quick sanity check here. Let's click M and select that. Let's just move that up. Repeat move copy. We're going to move this. We're going to change that pivot a little bit because I don't like how that would move. There we go. So put it there, and then click that little checkpoint to set pivot. That's how you can just change the XY coordinate plane of where you're actually moving from, which I find is handy. No, don't want to smooth that piece. This piece. There we go. Perfect. Repeat move copy. Oh, don't like that. Well, okay. What you can do is sometimes you can select a different part of your body to get that coordinate plane to move a little bit. If I select this circular line there, it's actually going where I want it to. Just look at where it's going to land and see if that's what you want it to do. So that indexes with that, that indexes with that, that indexes with that. Probably don't need, because this indexes with this, we may not need this to index with this, but I'm probably just going to add something really quick anyway, since it's easy as I've shown you. So I'm going to Control Z to undo those. Hide the mid pieces. I'm going to hide, actually just again, sort of sanity check. I'm going to raise that up. It would probably be easier for me to make a stub on this part and a hole on this part. Why do I think that? I'm not exactly sure. Some things are just a gut feeling. .3D printing wise, I don't think it's going to matter because I'm going to be printing this, the surface here, so it's going to print over. That's one thing you got to think about a lot too. And actually, if I do, so there is going to be in 3D printing, there is going to be some overhang here, which shouldn't really be that big of a problem, especially for a bamboo X1C or bamboo in general. I mean, they're so tight tolerance anyway. I'm not going to worry about that. I'll worry about it later if it becomes a problem. What I am going to have, my print orientation is going to be this is the bottom, that is the bottom. That is the bottom for that, because there won't be any overhangs there. The real interesting parts are going to be this. A lot of overhang in that. That's full overhang. That's overhang. The rest of it will be fine if I print this at the bottom. That's not a massive overhang for an X1C, but it is, especially since these are supposed to be really tight tolerance, it's going to change that a little bit. And that is one important thing to think about when you're 3D printing something, is the orientation. So that's going to be overhang, that's going to be overhang. But as long as it indexes at all, it'll be fine, even if it's not perfect. And something I could do, I'm not going to change it right now because I've gone through this whole process of making it this way, but I could actually just do a triangle. That way you don't actually have any true overhangs. So this would be, so my index would look like that. And that would be perfectly fine. If I do have a problem with my overhangs and the prints don't index with each other very well, I will go back and make that change. You could do the same down here. Like go all the way around, you wouldn't have a true overhang. But I'm going to hope, and this is a good test for my 3D printer to see how well it can print things like that. So it won't be a problem for me to just go ahead and add one to the top of these pieces. So I'm going to hide the top, click C, click on the face, go to the center point, make something like, let's just do a 5. It's a nice round, just round number. Go up 2, doesn't have to be crazy. I'm going to join because it's only in that piece. Actually, I'm surprised I didn't join that with that. Well, it did. So, all right, let's click this one. Actually, select it. There we go. Unhide that sketch. Where was that sketch? Right back here. All right. Click that. Go up to there. Join. And unhide the top. We're going to select the top. Sometimes they work so fast you forget to change back and forth between components, especially on a simple project like this. If you're dealing with like a motor with a whole bunch of different components, it's more easy to remember, like, hey, I'm working on a completely different part. Let me switch to that component specifically. So again, split body, select that body to split these. That is a splitting tool, and that is a splitting tool. Okay. Let's go and hide those two. Select that, body 1. Remove. You're gonna press pull. Nope, that's not selecting the right thing. Make sure you select the right thing, because that sketch is visible. If you're not using a sketch, just go ahead and hide it. Otherwise, you're gonna be extruding things that you're not meaning to. Negative 0.05. B press pull. Negative 0.05. There we go. There we go. It's just every piece indexed with each other. So again, as just sort of a sanity check, what I'm going to do is I'm going to utilities, section analysis. It's always good to, it's kind of fun to look around in the section analysis anyway. See some really interesting things. We don't need a gap in between there because we have that one there. So we have all 3 sides there. That's good. That's good. Perfect. Perfect. There we go. Okay, and what about... Right, there we go. So I had to go backward a little bit to see this. Here, got all 4 sides there. Got all 4 sides there. All 4 sides there. Perfect. Okay, so let's go backward. Let's see. We should also see a little bit of a gap right there, because that's what we extended the face of this backward 0.05. So that's good. All right, that is mostly ready in terms of just the 3D model that indexes with itself, but in terms of actual real world application of making this to be an actual mold, we want to make sure that it doesn't come apart in the curing process. So there's we're going to probably clamp this. So obviously that's a good clamp surface. That's a good clamp surface. Well, those two. Those will clamp perfectly with each other, but these won't. I mean, you could put a clamp going this direction around those and it might hold, but because they're circular, it could rotate. So what we can do is we can just add a small flat face throughout this whole thing. So the section analysis is here, downward. We just have to make sure that we don't go beyond this green part, because then we'll be cutting into the actual. So we can go in a few millimeters. So what let's do, let's go back to solid, let's make a sketch, I want to actually let me make a sketch on this plane here that I'm looking at, the section analysis plane. But I can either construct a plane here and come up to about where that is if I really wanted that specific section plane there. And let's see. Section analysis. It's your section analysis gives me under analysis. We should be able to see, I guess it's not going to tell us how far down that was. If we went back and redid it, we could see how far down we went from the top, but it doesn't really matter. So let's just make a plane bottom. Let's go up to about there. Let's just do L for line on that plane. And what we're going to do is just make some kind of, we could just do R for rectangle. Oh, that's not enough. Yeah, that's too small. Let's go about right there. Maybe about right there. And if you know exactly the size of your clamp surface, the plane of your clamp surface, whatever you want to call it, the teeth of your clamp, whatever your clamping surface is on your clamp, the size of that thing, you can make these size to fit. Make sure that what you're doing here isn't too small. Obviously, too large is typically perfectly fine for a clamp, but too small would not help. So we're also going to do that same thing up there. But to get these to be the exact same, we can project this down to this plane. Okay, now we can take a measurement from the center point to the rectangle, and then this is where the constraints come in. We can just click equal. We can make that equal to that. So now if I change one, it'll change the other one. Now they're exactly the same distance apart. What I can also do is I can click L, zoom in a little bit, project that and that. Click L, go from that to that. Now I can get that point right in the middle of that wall there. All right, there we go. Click Finish Sketch, go back out. Let's turn off our analysis. Get a better idea of what we're doing. We're going to extrude really just that part right there. Well, and that one. Let's just select both full rectangles. So we're going to go, let's just do symmetric. That way we don't have to do anything crazy. We're going to cut. It should cut everything just like you can see there. And ta-da! Now we can clamp these to the top and the bottom to the mid parts. And then we can clamp the two mid parts to each other. This is what I would call a complete first run, first trial for a mold for silicone. So this is what I'm going to 3D print and try out. So I'm going to save and make sure everything's saved so I don't lose any of my progress. So now we're going to pull this into Bamboo Studio and get this thing printing real quick. Okay, now that we've got these pieces mostly ready for version 1 prototype, we're going to click on the body, right click, save as mesh. Make sure these settings are right. We're going to export it. We've got one object selected. We're going to do STL. ASCII, that's what I've always done. Unit type millimeter. Not really going to mess with refinement settings, so I'm going to name this front, bottom, whole piece. I'll do that for all of these. auto arrange. Of course, it did not select the right bottoms, so lay flat with that face. We're going to, that one's good. This one is, oh wait, no, it's not. Oh, we could do it that way actually, but I'm not going to. I'm gonna select that, lay flat on that one, lay flat on that. All right, now that they're in their proper orientation, auto arrange, arrange. Okay. Auto arrange works really good at getting them as close as they could be to each other. So you can print a whole bunch of things all at once if you already know that the print is going to work well, which I don't know that this one's going to work well, so we're not going to do that. I am certainly going to turn on support for this one. Tree, auto. Let's slice that, see what it looks like. That is not what I want it to look like. No support. Why is there no support? Undo, remove, small. So it might actually be worth it to just run it without overhangs. If it said remove small and it defaulted to that, maybe Bamboo Lab knows that that's such a small overhang, it's not even going to matter. The printer will just go so quickly it won't even affect it, although it will probably affect it over here. That's where I'm worried right there. I don't know. I guess we'll run it and see. If it's not terrible, I can always trim off what wasn't good, and yeah, just go with what is good. So that's that. I'm just gonna do it in peel a basic. Also forgot I do have TPU ready to go, which I mean I could literally just go and print that thing. I could just come print that in TPU and it would be flexible enough. It might even work. Might even work darn well. I don't know that it will though. So I'm not gonna rely on that. So might end up trying it and see how well it works, but I'm gonna start with this. I also have never done a silicone mold yet, so I'm looking forward to getting this under my belt. Seeing how well it works, seeing what I need to change. So let's go get this on the printer. All right, so here we have the finished piece, and as you can imagine from a Bamboo Lab, it is pretty darn crisp if you've ever printed with one or have one. So it seems like some of these tolerances are a little too large. It is really hard to get that together. Let's see, maybe that direction. Yeah, probably gonna have to increase some of those gaps. But this print took 40 minutes, really no time at all. So those are definitely gonna have to increase a little bit. See about that. Yeah, those are just, yeah, it looks like the widths are good. The height is what may be giving me a little bit of trouble. So you don't always want to just increase everything. Sometimes you just want to increase only what you need to. Oh man, if I really press down on that, I can get that to go. But you can sort of see a little bit of, well, actually, that may have been how it printed. Maybe that's
It's because it's the overhang there. So the actual true dimension might be good, but because I don't have any supports on, that may be what's giving me that slight height layer difference. Overall, it was a great first test print. Yeah, and now that I took that little mismatch from from there being a little droop right there because of no supports, it does actually snap together. It's not perfect, but for a first go, see that works pretty well. That's a nice friction fit. The one going into there, and there's no support issue on that one. So maybe I just need to either print with supports or do that one in a slightly different way. Let's see. Yeah, there's just ever so slightly a little layer issue there. Probably not the smartest way to do this. I'm kind of cutting toward myself. But one way to quickly take care of that, the height of this doesn't matter. It's more of the side to side. The height is going to be taken care of just by it being on a plane surface. So I can shrink that up on both sides and leave that hole the same, and that'll be perfectly fine. So a lot of times with 3D printing, it's not about doing it the best way. It's just about getting something to work. Let's see if this one fits. Well, that fits pretty perfectly right there. Of course, this one's not going to work because the other one, because of that. But those two side ones work. So really only one of these, somewhat two of them. I should probably increase that or decrease that height there so that it won't interfere with that, and then we should be good. And then decrease those two, and then we should be good to go. So I'm going to make those changes real quick and then do another print. So I'm back a few days later. This new silicone gasket. So I did go ahead and raise the extruded part that indexes into the recess parts, and this thing's got a tight fit once you actually press them all together, which will be nice. You want a tight fit on something like a mold. We're still going to have some little lines. Anytime you have like injection molded plastic, you'll always see these tiny little lines. They get tinier the better the injection mold is. But so this part right here, I'm not sure how well you can see that. The parts that stick out, I extruded up into that part there. So it's not going to fully fill the recess part there. So I'm not focusing very well on that. So I just gave it a little bit better fit on those parts and on that part there. So on that part there, the light is right. Instead of having that be a full fit to the recess part, I just took it up a little bit. Very small amount, very easy to do in the software. That's the only part that I changed. Everything else was a decent fit. So now that we have this ready, we can really go ahead and start filling it with silicone and seeing how well the first trial goes. Probably not very well, probably gonna be some problems. But we will tackle those if we run into them. So one thing that is going to be very important to do is to wrap all these open edges with tape. We don't want that silicone that we put in there to run out those sides. And it shouldn't do that as much because we put those little things in there, but there's going to be little, it's like water to some degree. It's thicker than water, obviously, but similar to water, it's going to find every crack and crevice. So we're going to tape those up so that really the only crevice that it can even come out of is that hole there. So it shouldn't take too much tape, but you don't want to skip that step. It is great that it's such a tight friction fit. If yours isn't, you might want to go and decrease the amount that you pulled those away from each other. That way it will be a friction fit. All right, so let's get going.
So now that I have the mixing cups, the graduated mixing cups on hand, we can go and mix the silicone. So one handy thing about design software like this is that you can actually get a quick guesstimate for actual how much volume that you're going to need. So if you just right click on your piece, and that's what we're actually casting in silicone, select that piece, right click on it. I might have to right click on the body and not the component properties. All right, volume. Okay. Millimeters cubed, 5,000 cubic millimeters. Let's throw that into Google. All right, so let's see here. What was that exactly? 5551. 51 cubic millimeters. Let's see what types of volume we have on these little cups here. All right, we've got fluid ounces and milliliters. Well, let's go with milliliters. 2 milliliters. I think I spelled that right. Oh, duh. Forgot that it's such an easy. The metric system is much easier to use. What do you know? All right, so 5.55 total. Divide that by 2 because we have 2 different parts. So just over 2.5. Because that's such a ridiculously small amount, I'll probably do like 5 mils of each, so 10 total. So roughly doubling what I need. But that's a great handy tool of software like this. Figured I'd show you that if you didn't already know. So now that we have that, let's go ahead and mix some of this stuff up and get going on our first trial.
Okay, so now that we have our estimate on how much silicone to use, that way we're not making too little and then starting and then realizing, oh no, we have to mix a whole other batch just to get through. You want everything to be done all in one and to have a little bit of excess left over. Better to have more than what you need. And the estimate that we made on Infusion 360 is just that. It's an estimate. We don't know exactly some gaps that may be in here that, because this 3D print's not going to be 100% perfect to that. Maybe actually smaller than what that gasket is, maybe larger. So again, it's always best to have a little bit of excess left over. So let's get this thing put together real quick. So definitely one thing that is highly recommended is surrounding this thing with tape. And this is the quickest tape I have on hand going around and hunting a bunch of different stuff. And it's probably one of the best ones. It's going to come off really easy. It's just like, it's like that blue tape, blue painter's tape, but green, the frog tape, whatever. So maybe it's better, maybe it's not. As long as it holds this stuff in from leaking everywhere. So I'm going to try and come up with the best orientation to tape this down all of these seams as best as possible, because those seams are not going to be perfect. Just don't want to go over those holes, because that's where we're pouring silicone in, and then the other holes where the air is coming out. All right, there you have it. It's all taped up, ready to go. All those seams, everything except those two holes there. Now, I'm gonna go get, if I have one on hand, I think I do a syringe to actually inject that in there. Otherwise, I'm gonna need to print a little funnel to funnel the silicone down in there. I think I've got some little plastic syringes from Tractor Supply for giving some of my chickens some different supplements and medications and whatnot over time. Hopefully I can find one of those. If you don't have one, just go to Tractor Supply. They have all sorts of different sizes. And it would have also been smart to pre-size, pre-dimension that needle and make sure those holes are big enough. Otherwise it's just going to be sort of freehand in there. But yeah, let me go see if I can find one of those. What do you know? I thought I had something and I did have it. And it was actually relatively where I thought it was going to be. So this is what I'm talking about. This one is a 12 milliliter or 12 cc. I think that's the same. A cc is 1 milliliter, if I remember correctly. So I just rinsed this thing out real quick, washed it with some soap and water. Now I'm just making sure there's no water in there. I don't want to be mixing any water with the silicone. But it looks like this. That's actually the perfect size. It's a little smaller than I'd like it to be. This is a little too small, but it's better to be too small and actually fit in that hole than to not fit in that hole. So these things are like $1, $2 maybe. So this will be a perfect device. I mean, if I didn't have to mix the silicone, it'd actually be nice to just suck up 5 of one, a 5 of A, and then another 5 of 10. But then I'd have to like mix it in here, and that wouldn't make much sense. So we're gonna mix it in this little thing. This is one of the graduated cups. Goes up to 30 mils. So if that's enough for what you're doing and get some of those, they also make them in all different sizes. So I'm also gonna get this little guy. Once I fill this thing up, I'm just gonna drop it in there because these things are prone to leaking. So don't let it leak all over your desk or some other work surface. All right. Let's get out the stir sticks, let's get out some gloves just to be safe. These chintzy, terrible gloves, but I guess it's better than freehanding it maybe. All right, so we've got our A right there. This is BB Dino. It's just one of the not crazily expensive ones. It seems like it's pretty decent. I think this was like 30 or 40 bucks for 2,000 grams, whatever that equates to in liters. And I guess it'll end up being a little bit of a blue color. Let's get this junk out of our way. So I read the instructions. Let's just say they leave a lot to be desired in terms of how well they're written. But all right, mixing ratio 1:1, 1A to 1B. By weight, it's recommended, or volume. It's going to be well, actually, they could be different densities. We're going to go with volume. Mixing time 3 to 5 mins recommended. Working time 10 degrees Celsius or 50 Fahrenheit, which we are not at. We're closer to the 73 Fahrenheit. About 50 minutes working time. Curing time is 5 hours at this temperature. So this is the 30A, which is self-degassing, which is good because I don't have a vacuum chamber yet. Trying to make a vacuum chamber work. So the no degassing is the 35A or the 45A or 40A, not 45. All right. That's pretty much it. So I kind of wanted some instructions as to like whether or not you're supposed to like mix this stuff. I have no idea how well this stuff stays mixed, but we're going to mix it up anyway. So start with A because it comes first in the alphabet. No other reason. Of course, after I get my gloves on, I realize there's one of these things on here. I'm sure these gloves are making a bunch of great noise for y'all on the mic. Hopefully it's not too unbearable. All right, so with this kind of lid, what I'm gonna do is cut a little triangle. These are actually really nice to not just rip off completely, because now I can control how quickly this will come out. With a very small triangle, because I don't need much. And let's get this whole napkin here. And this stuff is non-toxic, but I still like to be cautious with just random chemicals. All right, so I'm going up to the 5 milliliter line, which is about right there. Very, very small amount. So I'm not going to move the camera so y'all can see this. Just know I'm going up to 5 mils with A and then up to 10 mils with B, which would obviously be another 5 mils. So let me get down on the floor here so I can really dial this in. Go really slowly. All right. Get a little napkin. Wipe off that. Put the cap back on, keep that stuff good for hopefully as long as possible. All right. Now B. Okay, so that is both parts, approximately 5 milliliters each. It is 7:56, so starting about a 5-minute timer for stirring. I am kind of interested to know what would happen if you're off on the pour a little bit, like instead of being 50-50, what if you're 60-40, 75-25? I might do some trials just to do that, do like 10 different graduations of different mixtures, different percentages, ratios, to see what happens with the final product. You know, does it even set up? If it does, is it harder? Is it softer? What happens if there's too much A? What happens if there's too much B? So at some point, when I have some time, I'll hopefully get to that, because I'd be interested in how critical is it? You know, if you're 60-40, is it perfectly fine either direction? Are you better if there's more A, better if there's more B? It's probably better to do this with mass, because mass is a little bit easier to do to some degree, because you're not eyeballing it with a level, level of how high the liquid is, which your eyes can be off on. I mean, it's easier to look at a number and be like, okay, the other one was 43 grams, this one's 43 grams, that's 50-50. So I might recommend doing that. You can get your typical kitchen scale is going to do down to the grams. It'd be nice if you add tenths of a gram too, but if not, then hopefully it's just better in general to do it by weight. right, so it's been about 5 minutes of stirring. So I'm going to take off this foolish glove that I never should have put on in the first place. I'm going to get on the paper towel. Oh, I'm actually just going to put this stick, I'm going to let the stick drain off and then just put it on one of these used gloves. And I really hope this is self-degassing because you can definitely tell there's a lot of bubbles that have been incorporated in. It'd be so nice if I had a vacuum chamber to degas this, but hopefully soon. All right, I'm not going to look for any more of those drips. Let's get the syringe ready to go. There's clearly some bubbles in this syringe. I'm going to hopefully let all those come to the top and then get all that air out. I don't know if you can see that. Yeah, there we go. Let all those bubbles go to the top, get that air out. All right, what do you know? We are ready to rock and roll. Oh, oops. All right, here goes, first try. So I'm going to hold it a little bit up like this so the air naturally accumulates on this side. I'm going very slowly. Just trying to let that slowly pour in. I want it to form one large air bubble in this corner over here. I don't want a bunch of tiny ones in there. And I may have to, it's good to sort of agitate this a little bit to sort of try and knock it in. So I've got some small crevices in there. So it might be beneficial to rock that around back and forth. Try and get it all in there. Oh, I just saw it come out the other side. So it was good that I made more because I think it took more than what my estimate was. I didn't notate how much this actually went up to on the syringe. I probably should have done that. But now that it's coming out the other hole there, I'm going to sort of knock it around with my finger, try and agitate those bubbles a little bit. It does look like it's receding on the other side, which means I think it's filling in more of those crevices. Oh yeah, definitely filled in quite a bit. Oh, not much. It came right back up to the top there. Okay. So now I'm going to just get a little bit more in that first hole. Sort of, the top is covered. I don't know how well you can see any of this. Sorry, the camera's not perfect. It is covering sort of the whole top there. I want that to just sort of help fill in the holes if it finds any gaps that have been created by some air bubbles coming out. Get that at the bottom there. We're going to cut off all this excess later after it sets up. So we poured it almost right at 8, so 5-ish hours from now it should be ready to go. So tomorrow morning, hopefully I'll wake up to something that's not a complete and utter failure. I am just going to go ahead and get all that excess out and then go wash this so I can hopefully use it again next time. All right, so that's it for the first version 1.0 prototype. Hopefully it isn't a complete failure and waste of time, but regardless, it's been a learning experience, so I'll check back in with y'all very quickly. For you, probably 12 or more hours for me because I gotta go to work and wait for this to set up and all that. So yeah, be right back. Okay, so here we go. It is the next day. I'm hoping that this is fully set up. The top part that you can see in there feels like silicone. Separated from the little plastic cup like silicone, at least I guess. Yeah, that seems like silicone. at least what came out of the mold setup. I'm wondering how parts that are not open to the air set up, which probably pretty well. I mean, people do this all the time. This is nothing groundbreaking. I just don't understand how it sets up. It must not be an aerobic reaction. It actually feels fairly strong. I mean, so the part that's connected where it actually goes in the hole is pretty sharp. I'm gonna wish I had like a scalpel, which I do somewhere, but I'm not gonna take the time to find it. I'm just gonna use my little pocket knife here. Maybe I should get that scalpel. This stuff is pretty resilient. All right. All right, that was the top piece, and that's silicone for sure. Yeah, very simple, very easy to use. It's even got the texture for my print plate on there. That's kind of cool. Let's get all this tape off. All right, over there. All right, this is going to be the hard part. Actually, getting it to separate, probably anyway, the hard part. I don't recommend doing this at home. Aiming a knife at yourself like this, probably a better way to do this. You can definitely tell some stuff oozed out of the side a little bit, so that tape came in real handy, which I was expecting that anyway. Now there's just little shards of silicone everywhere. They let it stick to everything. I think they get statically charged pretty easily. All right. Actually, this happened to have, this literally was not planned, a little pick set here. This might come in handy to help pry apart. Little sharp little picks, straight and hooked and different things. Hopefully if I just, there's a nice 3-part joint right there. If I just, jam that in there maybe. Okay, this thing is solid. Oh, there we go. All right, so going in on the side right there with just a little bit of force helped open it up. This part you don't want to rush, because if you go too fast and rip the thing in half somehow, then well, you got to start all the way over. Just gonna go very slowly twisting the knife, trying to separate. Try to get the top off now. Oh, there we go. Oh, wow. That actually separated really smoothly. There's nothing that stuck to that. There are a ton of little parts I'm gonna have to shave off with some kind of scalpel or a really sharp knife, because it gets so thin where it squeezes out of the sides where the pieces of plastic come together. Actually, get some of this green tape I had. Just stick the little thing, I don't know if you can see that on there. Just stick it to the tape, and the tape will make it magically disappear. Wrap that in a little circle there. Now I can use that to sort of just get all that stuff off, at least what's loose already. Once it comes loose and sticks to my hand, I just stick to the tape. All right, let's get this thing the rest of the way out of here. All right, I split that side. Now let's split this side. No, that's the side I split. Switch this over here, split that one. Split this bottom off. Try to make sure I don't go too far in to the actual plastic. I don't want to cut any part I want to keep, obviously. All right, that's just so cool once it actually like separates. Look at that. That is like perfect. That was so easy to do. It's harder to get the thing out of here than it is to cast something in silicone. Now this part is probably going to be one of the harder ones to get out because it goes all the way up through the middle there. And there was another little thing that came with the silicone set. I think it might be something to help shave stuff off. Oh, and that. Oh, that's poor manufacturing. So it does look like a little knife thing. I don't know what background to put that on so you can see that white there. It looks like you just sort of go up with a seam with this, but it's so poorly manufactured the thing just popped right out. So if I have some super glue around, I can super glue that back in there. But I think that'll sort of help go along these edges where the seams are, maybe. Seems to be doing exactly what I thought it would. Yeah, that's definitely what this thing's for. And it actually is pretty nice. It's very, very thin little blade at the middle of this thing. Just helps separate that a little bit. It could be better. I'm sure a scalpel is going to work even better. Take to the rescue. All right, so I'm gonna try and like spin this, I guess, to have that release. I really don't want to move. There's so much surface there. There we go. Nice. So much of this excess stuff that just oozed out. Yeah, at this point, I don't know if they have like special silicone trimming tools or something, but if you're wanting to do some silicone casting and molding, I would probably Google that, Amazon, search that, just to have a bunch of different shapes and sizes and help trim your part up, because this stuff is, it just gets everywhere. You're not going to have a 100% tight mold with 3D printing. It's just, resin 3D printing is going to be a lot better because the tolerances are just layer lines and just everything is much better on a resin printer, and I don't have one yet. Maybe one day. I'd love to get one. No idea what brand I would get yet. I'm not gonna lie, I was thinking all day about this at work, and I'm like, that thing's gonna fail. Something's gonna go wrong. It's just not gonna work. And I don't know that the thing's actually gonna hold air in my vacuum chamber, but this thing has turned out far better than I thought it would. For my first try, I've never done any cast of any kind of material in any way, shape, or form. Granted, I'm sure silicone is probably one of the easier ones, but still, to just jump right in. I'm not gonna worry too much about cleaning this whole thing up. I do need to get the entire thing up. I do need to get this hole though. All right, so I kind of like this little blue color. I mean, you can clearly tell how silicone this is. So I do need to cut these off. Probably gonna take some time to find my scalpel set before I do that, because I do want that to be relatively decent cut. I'm not going to get that with this tiny little thing. This is just for getting all these little side things off of. I cannot recommend enough. Have a piece of tape right there with you to get those things off your hands, otherwise they'll end up all, it's like glitter. I mean, all right, but let's see here. We have the pressure gauge valve stem. So, oh, that's a nice tight fit. That's spins just a little bit. That works amazing. All right, so found my scalpel set here. Found it very quickly because I actually organized. Heads up, if you haven't seen them yet and they're already published, check out my organizing videos. incredibly important for efficiency and success. I'm just cutting off these excess parts here. Alright, that was pretty simple with scalpel blade. I don't know if I'm going to be able to get any more of this other little frayed stuff off, but if not, whatever. It's not going to matter for this purpose. If you're trying to make something you're going to like sell to people, well, good luck. This is going to take a lot of extra attention to detail. Alright, that's all the cleanup I'm going to try and do. Don't really feel like I'm getting any further with that. But I'll take this tape and get all those other frayed bits taken off. Alright, so now the goal is to really get this thing in this hole. Looks like it'll fit. Sort of just roll it in half and jam it in there. Want a decently tight fit. Oh, there we go. What do you know? All right. I'm also gonna have to do a test run of it with the vacuum pump. Make sure it'll hold a full pull on the vacuum. -1 atmosphere, -30 inches mercury. It's pretty darn difficult to get this thing all the way in the hole. Now running into a little bit of a problem. It seems like it's not the stem not quite long enough to get the actual threads of the bolt on, or the nut on. I was kind of afraid of that. Can probably take the other washer off and it give it a little bit more room, hopefully enough to get the, because I don't really think I need those nuts on there. I think it's such a tight fit, I'm not going to really need that. I guess we'll find out. Alright, I was able to get the nut on. The more I tighten this down, I'm hoping that it's actually going to mushroom out what's surrounding the shaft that's going through that hole in the glass. Or plexiglass, I don't exactly know what that is. It feels like glass, but it's about as tight as I can get it with a hand. You can sort of see that it's mushrooming up this side here, which I think is fine. I think that's, if anything, I hope it's going to help us. All right, there we go. Okay, so here we have our full system set up, I think, properly. Got our good old Vevor aluminum can there. So I haven't shown this yet, I don't think anyway, but just silicone rim around the metal there just to help, another silicone rim around the glass. Now our specially made silicone ring going around the brass thing there, so I want to make sure that that's on there properly as much as possible. Make sure that's sealed all around silicone there. I've got a dial here. Got our pump here. This is a Vevor home pump. I don't think a very good brand. I mean, it works. I had to vacuum down a mini split AC system with it, and it worked. So it works, but I wish there were more American brands out there. There's not really many American brands that have a even seemingly normal name anymore. But so now this came with the Vevor Home. This is our high pressure side. We're not going to use it. We're going to make sure it's closed. This is our low pressure side. We're going to make sure it is open all the way. These don't go to anything. It's just an end. It's just a, I don't even know what that's for. I guess you could switch out that connection for something else. This middle one plugs up to the actual vacuum pump. There's a little indicator in there with some oil. I guess that'll help you realize if there's bubbles moving through it or something. Don't think we need that. Leave that on there. So on the low pressure side, we have connected this rubber hose with some steel wire in it. Came with the Vevor system. So this came with Vevor, this came with Vevor, this came with this. Everything else came separate. Got this thing plugged in. I think we're ready to do a dry run. Now I'm going to leave this closed. This is in the closed position because I want to see if this will pull vacuum just on this hose to make sure that this, because that's not exactly how that's supposed to fit. This one is like a ribbed connection for something like this. This one's not a ribbed connection, so I want to see if I can actually get vacuum here first. So I'm going to leave this closed and just pull vacuum on the line. And then if this goes down to approximately negative 30 inches mercury, then I'll open this up and see if this one starts to go down also. And there is something on here that tells me I need to cut this little nib thing. Once it's installed, you cut that. So let me go get some scissors real quick. Okay, got some scissors. I don't know why this thing's on here. I don't feel like I've seen it on any other gauges like this before, but I'm gonna trust that they're not lying to me. A little bit of oil came out. Hopefully that's supposed to happen. I don't know why or how that makes any sense, but it says cut with scissors right there. But hopefully, if that wasn't supposed to be fully punctured, hopefully I didn't just mess the thing up. All right, here we go. Now it is quiet as go. We are at about negative 30. Sorry if this is super loud. All right, I'm gonna open this one now. Okay, so we're on about negative 27 inches of mercury. So I let it sit for a few minutes, wanting to see if the pump would actually continue to pump it down anymore. It didn't look like it was getting past negative 27. So before I shut this off, you want to close this to make sure that once this is turned off, it doesn't escape back through this system, or you can turn it off here. But that one's just easier and it's closer to where I'm working and looking at up here, and it's holding pretty well. So as you can see in that beginning part, when it wasn't really starting the vacuum, I didn't know, what was going on, because there's a whole bunch of pieces, parts here. You don't know what's working, what's not. But it did occur to me like, hey, why don't I try pushing down on this thing? If I had like a little smoke gun or a cigarette or something just to create some smoke, I could see running around the rim to see if it's getting pulled in anywhere. I don't have that on me at the moment. I don't have any other way to do that other than maybe some like a fog machine or something like that. They make tiny little smoke guns for like smoking food, and then there's other, I think, tiny little fogger guns for like a like wind tunnel or something. But I don't have those right now. So I figured I'd shut the system off after closing it here. Shut the system off, that way I can hear. All right, camera battery died on me. So, as I was saying, if I shut the system off, I can hear anything. I don't hear anything. It's been probably 5 minutes, because I had to go change my battery and do all that stuff. Still holding negative 27, so this has got a really great seal. And what I figured this would, because it's a product manufactured by a company, Vevor, because they're so great at stuff, right? So far it's working for me, so I can't complain that much, except for them not sending me a correct gasket, but hey, gave me a fun project to do. And that gasket is holding pretty well. I don't necessarily have a frame of reference for negative 27 inches mercury, but it's certainly vacuum. So I'm gonna maybe turn this on again, see if I can get any more vacuum out of it. I'd love to get like down to negative 30, but it may just take a super long amount of time. This is a 5-gallon bucket, so there's a lot of volume of air to remove, but it did sort of seem like it had plateaued. So that may be just a limitation on this motor, and I want to say it was a decent. It wasn't the strongest motor, that's for sure. I didn't want to spend too much money on my first. Don't know how much I'm going to use it. Of course, this oil is sort of leaking out a little bit up top here. All right, so here we go. Round 2, trying to get more vacuum. Okay, so it's been quite a while now. Not even a slight bit of change. So I'm thinking negative 27 is the lowest we're going to be able to get. Which, looking up online, it seems like that might be enough to at least do some decent level stuff. Wood stabilizing. It'll probably degas resin or silicone pretty easily. But for trying to like get wood to absorb like cactus juice or some kind of resin filler, you want to get as much as possible. And so I'm only at negative 26. Ooh, yeah, so that's even worse. It's still pretty decent. This is, if I remember correctly, this is a single stage pump. A 2-stage pump would probably get it even lower. This is a lot of volume of air. This pump and combo that came with a bunch of different little fittings to fit on there. It's really meant for vacuuming HVAC systems. And I had to get one to do that system, and I figured, hey, it'll work on this as well. And while it is working, I may at some point in the future get a 2-stage, but I think this is good enough for now. And it certainly is proof positive that this silicone works, even with some tiny little layer lines in there and maybe some little air bubbles here and there. I didn't actually see any air bubbles, but I'm sure there may be some that I just didn't notice because I was too excited to get it in there to really give it a good once over. But yeah, this is one way to solve a problem that you have. If you're doing any kind of hobby or any kind of anything in life, you're going to have to solve problems, and 3D printer is one quick way to do it. This was an aside, because this is another part of a hobby that I have for woodworking and making resin stuff and silicone, whatever in the future. This was just a great way for me to show how to just get on Fusion 360 or SolidWorks or whatever else you want to, or Onshape, whatever you want to use. I will be posting that design and those STL files, so you can throw them in your slicer and print them up if you want to. I also could have just printed this out of TPU. I have TPU sitting around, but I've never done silicon mold, obviously, so that's why I wanted to do that. Silicon cast, whatever you want to call it. So I hope you learned something. Before I let you go, I am going to break this vacuum, and hopefully it makes a fun noise. So hopefully this doesn't explode anything. Huh. Yeah, that was pretty cool. All right. Good to go. Thanks for watching.